think the simplest thing would be that the whole world just agreed to reduce emissions and then everyone trusted everyone to get on with it. But, that's probably not realistic. So
That's never going to happen.
Yeah, probably not.
Right? I mean, that's just never going to happen, which is the reason they're in creating this CBAM process, because they feel like countries like China and India and a number of others that have been absent of some of the world carbon dioxide conferences, I'll call them, because there's been multiples of them, that there's some countries that don't want to participate. So what else are you going to do? Welcome back to the Uptime Podcast. I am your co-host, Alan Hall, and I'm here with the commander of carbon offsets, the doctor of bladeology, Dr. Rosemary Barnes. And on this jam-packed episode, we have a number of topics this week. We have carbon capture, courtesy of Rosemary, and also carbon border adjustment mechanism, which is some EU way of imposing tariffs for people they don't like. Questions about mammals, sea mammals, and wind turbine noise. And there's some studies going on. There's actually been a lot of research about that. And where's the industry going? We'll talk to those issues. Can we build enough lithium batteries? I think the answer is no, but Rosemary's going to fill us in with the details. GE is building 3D printed concrete towers with our friends from Cobod. And also, is renewable energy a good use for cell phone towers that are in remote locations using vertical axis wind turbines? Another pain point for Rosemary. So let's get started. Hey, Rosemary. We have we have a group up in Europe called Climeworks that is working to remove 4,000 tons of carbon dioxide from the air, and a plant called the Orca Plant, which is the largest carbon dioxide removal plant in the world at the moment. Stats on it is, well, actually, it's broken. Actually, the latest news I saw on the web was that the system was broken because it's up north and it got too cold and the system froze, and so they're still trying to figure it out. But does carbon capture make sense? And do we actually is it going to really make any impactful difference on the amount of carbon dioxide that's in the air?
Yeah, so that's a really good point, and it's really kind of a controversial thing too. And it's where my opinion differs, I think, pretty starkly from most other, renewable energy professionals that I know, and definitely differs from climate activists who are mostly very, very scathing of carbon capture, and especially direct air capture, because it uses so much energy to capture like the really low concentration carbon dioxide from the atmosphere. And I did look up some stats for that and do some quick calculations. So in 2020, atmospheric carbon dioxide was 412.5 parts per million. So that's like 0.04%. So to get 1 ton of carbon dioxide out of the air, if you can capture it all, you need to move 2,500 tons of air. So, there's a lot of air moving around. And I mean, if you've ever plugged a fan in, then you know that uses a lot of electricity just to move the air. And then, not to mention actually managing to, grab those carbon dioxide molecules and do something with it. So it's definitely, I think in the past, especially in Australia, the way that carbon capture was sold to us, it was like in the form of clean coal. And it was like, we can have carbon capture and then we don't need to do an energy transition because, it's just like we're just going to put these, plants everywhere and carry on business as usual. And I think some people in the fossil fuel industry and some government people do still seem to think that that's what it is. It's like an either or. Either you have renewables or you have carbon capture and storage. But the reality is that it can never scale to the point where you could do that. You could have CO2 removal instead of, just stopping to emit CO2 emissions. And I mean, the main reason is just economics. So if you look at the Climeworks plant, which is the biggest and maybe one of the most advanced technologies that we have so far, it costs $1,200 per ton of CO2 to remove. And a bit cheaper. Apparently Bill Gates gets a 50% discount. He's he's paying $600 per ton for his bulk purchase, but that's way more than, abatement from swapping, closing down coal power plants and replacing it with renewables and batteries and, changing over internal combustion engines for electric vehicles. It's just, like a totally different level of costs involved. So you would never choose to just scrape it out of the atmosphere instead of, removing removing the emissions in the first place.
Well, is there a natural cycle that would happen here as we remove or we start pushing less CO2 into the air? Is there any sort of feedback loop that we've looked at in terms of the Earth's cycles that as we decrease CO2 emissions, that the planet will start to reabsorb some of the CO2 that has been created and it reaches some sort of equilibrium? Because the hockey stick curve I still see floating around, and we're on this catastrophic pathway to all life ending on the planet. But yet here we are 10 years later after the 10-year predictions, and we still haven't reached the hockey stick curve. What are we missing here? And is carbon capture even part of a long-term answer, or is it really just 1% of a 99% problem? Because we're talking about trying to move the carbon dioxide down from 0.04% of the atmosphere to 0.03% of the atmosphere. Am I right about that, roughly?
I actually haven't looked up what we would ideally like the atmosphere to be at, what it used to be at in terms of CO2. But yeah, okay. We need to. It's not that we have multiplied the amount of CO2 in the atmosphere by 10 times or something. It's definitely it seems like a small increase, but unfortunately the effect on the climate is large. And I mean, I'm no climate scientist, so I don't want to get into too much depth here, but my understanding from what other actual climate scientists are saying is that they're much more worried about positive feedback happening. So rather than that the Earth is going to shortly be able to, absorb more CO2 than it previously could, people are worried about, permafrost melting and methane being emitted from those areas and other types of things. And I do think that it's for that sort of thing that we are going to need carbon removal from the atmosphere. So that's where I see this place is. And I think you mentioned, maybe 99% of the job is done through stopping to emit and 1% of the job is done through sucking out carbon from the atmosphere. And it might not be 1, it might be, 2, 3, 4%, but I think that you're roughly right. And I think that that's going to be really important in, 2040, 2050. And so whilst it currently doesn't make any sense to spend all this money and all this energy removing carbon from the atmosphere, I mean, so this largest plant in the world, it's 4,000 tons. It's equivalent to yearly emissions of 862 petrol cars, or closing down 0.001 coal-fired power plants, or installing 1.1 wind turbines. It's not a significant thing at all if you look at the actual carbon that's being removed. And then the other thing is the energy usage. You use a lot more energy. So that's why they've located it in Iceland, where they have already a really green, pretty much 100% renewable electricity grid. So it's not emitting more to use this electricity there, but it's 3.9 watt hours per gram of CO2 removed. So it will need 5,600 megawatt hours of green energy to achieve its 4,000 ton CO2 removal target. I saw a post on LinkedIn from Gianni Catalfamo, who says that if the same energy was used to power electric cars, it would avoid CO2 emissions 2,000 to 5,000 times larger than what they're going to achieve. So for today, it doesn't make sense. But since we're going to need it in 2040, 2050, and it is a very challenging technology, I do think that we need to work on these technologies now. However, we need to be able to work on them without all this media buzz that goes with it that makes people think that we're doing this instead of removing reducing our emissions, because it's not one or the other. It's emissions reduction is the big 99% thing. And then this is the 1% thing we need to work on for the next 30 years to make sure it's ready in time.
Yeah, well, I think you raised sort of a really good engineering point here. Is everything needs to be put in perspective, right? And when we leave journalists to the task of putting things in perspective, we always lose track of where we're at, because most journalists are not mathematicians, they're not scientists, and they're definitely rarely engineers. So we lose the focus of where the emphasis should be, and the emphasis should be on emitting less carbon dioxide and not trying to recapture it. Recapturing is probably part of it. And in that effort to reduce the amount of carbon dioxide that's emitted into the air, the EU is putting out a bunch of new rules, like the EU likes to do, about carbon emissions. Now, they have a new program called the Carbon Border Adjustment Mechanism. Now, first off, that name really is bad. Okay, it doesn't translate well to English.
No, but you got to use the acronyms.
Maybe it means something else in French.
CBAM.
CBAM.
You got to call it CBAM. Then it sounds catchy.
Well, it does. It has a nice ring to it, right? So they're planning on some market changes in 2023 to look at carbon emissions and impose tariffs on products that create carbon dioxide, such as cement, I guess coal-fired plants, any kind of product that is generating a lot of CO2 as it is created. When it's imported into the EU, they're going to impose a tax on it because of all the CO2 emissions they couldn't otherwise tax. So let's just use a case in point. So if there was a factory in South Africa that was making cement, and that cement was transported up to France, that South African cement would be taxed based on what the theoretical CO2 emissions were to create that cement. Now, I think this is a little nebulous on how this is going to be done, because how do you know how much CO2 was emitted when they created that cement product? You really wouldn't. Maybe renewables are highly in use in South Africa, because I know there's a number of wind turbines down there. Maybe they're using clean energy to create the cement. Maybe they weren't. Who knows? But it's a very confusing, vague process. And I'm as an American, I'm always struggle if there's confusion. There's a lot of bureaucracy in the way that doesn't make a lot of logical sense. That means there's a lot of places for nefarious activities to happen. There's a lot of ways that politicians and bureaucrats to kind of weasel their way in there and create these uneconomic conditions. It seems like this is right for it. Now, this whole process is based on the price of carbon dioxide, right? Rosemary, do you know what carbon dioxide prices are right now in different places of the world?
Yeah, so that was
roughly.
That was one of the interesting things, or the reason why I wanted to talk about carbon prices today, because they're really high in Europe at the moment. They've just closed the week at nearly 89 euros per ton, which is about $95 US. So we can compare that back to Climeworks' $1,200, and you can see, there's a huge mismatch there. But they are, I think that's the highest that they've ever been by quite a way. And it does start to make some technologies like regular carbon capture and storage, where you're taking the concentrated CO2 out of flue gases from a power plant of some sort.
Right.
It's in theory not that much more than $100 a ton. So we are kind of getting close to that. But the European scheme, it doesn't include everything in it. And as far as I'm aware, it doesn't currently include cement and other, industrial products. And one of the reasons for that is because if you tax that in, or if a European cement plant had to pay for its carbon emissions, or maybe a better example is like aluminium, because that's a bit more transportable than cement. If that had to pay for its emissions, what's to stop a country like Australia, which has, not really strong regulation on carbon emissions, what's to stop us then selling to Europe for a lot cheaper than the Europeans can compete with, because they're paying the carbon price and we're not paying it. So the CBAM is supposed to take care of that. Like you said, it does open up definitely several cans of worms, and it is quite challenging. I think the simplest thing would be that the whole world just agreed to reduce emissions, and then everyone trusted everyone to get on with it. But that's probably not realistic. So
that's never going to happen.
Yeah, probably not.
Right? I mean, that's just never going to happen. Which is the reason they're in creating this CBAM process, is because they feel like countries like China and India and a number of others that have been absent of some of the world carbon dioxide conferences, I'll call them, because there's been multiples of them, that there's some countries that don't want to participate. So what else are you going to do? They're going to basically impose fines on them. But I just don't understand how this process is supposed to work. And I still don't understand that how you apply a price to carbon dioxide. Because as we can see already, the pricing in Europe and the pricing in other countries that have carbon pricing or marketplaces is wildly different. It's like saying the price of gold would be different in America versus South Africa. They should be the same, right? The value of that in dollars or reals or whatever the currency would be identical worldwide. And yet we don't have a carbon tax or a carbon price that's stabilized because it's sort of mystical, right? It's essentially a tax. They can make the tax go up and down as they please, right? There is no marketplace for carbon dioxide.
There is. Right? I mean, there is. And I mean, in Australia, we don't have a tax. We briefly had a carbon tax for a while, or an emissions trading scheme, and it was removed. And so we still have a price on carbon in Australia because we have, some voluntary offsets trading systems, and then the government is also buying offsets from companies to, give some semblance of a climate policy and stuff like that. So we do have a price on carbon in Australia, even in the absence of a tax. But because I'm not an economist, and maybe we should get a financial analyst or somebody who can really talk through this in depth on the show.
Yeah.
But my understanding is that at the start of your decarbonization journey, you've got heaps of low-hanging fruit, really easy, really cheap stuff that you can do, like energy efficiency projects, or not cutting down some trees that you were previously thinking about cutting down. All that's pretty cheap. And maybe that's where Australia is now, where basically all our emissions reductions come from not cutting down trees that we say we would have otherwise. Whereas in Europe, they're a lot further along. They already cut down all their forests hundreds of years ago, so they don't have that option available to them. And they're doing a lot more expensive things now to get carbon. Also in Europe, it's a proper scheme where they are ratcheting down the amount of carbon dioxide available to trade every year. So theirs is actually designed to reduce emissions in a way that that some of the other systems aren't. But I think, eventually Australia's original emissions trading scheme, it was eventually planned to be tied to, other markets when you do allow cross-border trading. And I think that would be like the mature place that you would aim to end up, because, the planet doesn't care if Europe is down to, 10% of its emissions while Australia is only at 90. It would be better to spend your money reducing Australia's emissions all the way down, rather than really expensive small gains in Europe. You want the big cheap gains in Australia, or it's a lot in developing countries, a lot of really easy wins there that will have the same effect on the atmosphere.
Yeah, isn't this the same discussion we were having about carbon capture, that if you're going after the 1%, you sort of miss the 99? In this particular scheme, it seems like we're aiming at the 1% here and sort of missing the big picture. There is no market for taxation. There just isn't.
What I do think is a real effect of this CBAM, it gives it will allow Europe to include a lot more industries in their carbon price, which means there will be a reason why people would bother to change their steel manufacturing plant. They would bother to change it over to hydrogen or electrolysis or something. It would be more give like people a reason to make CO2 neutral or reduce CO2 cement, because currently I think I saw someone estimate that if you put just Europe's existing carbon price on cement, it would make the price go up 50% or something. So,
but why would you do that? Why would you do that artificially? Because either you make the energy prices lower, right? The problem we're having in a lot of places is that the energy prices are too low, or that's a good reason to use electricity versus petroleum products or whatever, coal or whatever else, is that the price of electricity gets so low that it doesn't really make any sense to ship oil from the Middle East to Pennsylvania to make cement. That doesn't make any sense anymore. Or to dig coal out of Kentucky to bring it up to Pennsylvania to make cement. It would make a lot more sense to do it with electricity. If the marketplace for electricity gets driven down, which clearly is, why would you not continue to drive it down and just naturally everybody will switch over anyway?
Yeah, no, I agree with you that when it
Okay.
comes to renewable electricity, that's true. And that's why you see like Australia has been installing more renewables, or, our proportion of renewable electricity in the grid is rising faster
Right.
than nearly any other country at the moment. And we have very close to zero policy reason for that to be happening. However, cement's emissions don't come from electricity usage. It's and same with steel. It's there's plenty of industries that aren't just more cheaply served by zero emissions technologies.
Okay.
And in those cases, if
Sure.
you want to capture those, and I think cement and steel each make up, like something around 7-8% of global emissions, each.
Right.
Not to
Yeah.
mention, aviation. I don't think that you would think that
Easy.
electric aviation is just cheaper than using, aviation fuel. It annoys me actually. People talk so much about aviation. It's less than 2% of our emissions, but there are plenty of emissions that come from things that can't be solved by electrification. Agriculture would be another one, and a lot of transport is not easily electrified. If you look at
Right.
heavy transport and shipping and aviation, at least. Yeah, electric
Right.
cars are easy.
It's just two different philosophies here, and I think we're going to find out which is more successful. But if you don't have everybody playing on the same playing field, and you will not ever have that, then you have to figure out another way to make things happen. And I think one of the easiest ways to make things happen is to lower the price of energy via renewables, and everybody will switch naturally. It'll be the way to go.
Yeah.
And there's also social pressure to do it too. So I don't think you need to set up a really complex system run by the EU to do some of these things. I think a lot of it's going to occur naturally, as it has over the last 10 years in the United States.
Yeah, but we won't get all the way there. We'll get about 2/3 or maybe 70% of the way there from the things that the market can sort out. And I mean, that's huge. And we definitely should be doing more to, speed that up. And I think that, the bulk of emissions reduction is electrification. And the fastest
Yep.
way to speed that up is through making sure that your market is set up right, because these clean technologies just are better. And if you change at the moment, the playing field is really skewed in favor of the incumbents, fossil fuels. If you get rid of some of those historical kind of regulations and market mechanisms, then we could go really fast on that and make a bigger change faster,
Yes.
which the atmosphere needs. But I do still think that for that remaining, it's 20-30-ish%, it'll need something more. And there we do, like, what's the reason why anyone would bother to start looking into alternatives to cement that can be lower emissions? Because you'll never get rid of all the emissions from cement, from
No.
fertilizer, without
Right.
some like really different thinking. And this is one way to do that. I mean, what's the other option? That governments just pay people to do research? I don't see that working out so well on its own.
No,
usually.
no. No, I think it's been shown over the last 20 to 30 years that bringing countries out of abject poverty has a lot to do with reducing pollution of all sorts, not just CO2. And the faster we can get to a more stabilized world economy where we don't have major countries and billions of people living in some sort of poverty conditions, you're going to see the planet clean up much faster than any other way of going about it. And if you want to tax those countries into oblivion, which you can clearly do if you choose to, you're going to slow down progress. And ultimately,
I don't know
it's
if
about
I
the
think
speed of
it's-
progress.
I don't think it's going to
sure.
tuck them into oblivion. It's just for a few products that are carbon intensive. that are, going into Europe. So
No, I think India. Let's just use India as a case in point, because India is a country that is evolving very quickly, and they are headed towards a renewable future. At least that's what it seems like right now. And if that's the case, we should encourage that, right? We shouldn't slow that down. And it may be rough in the middle years as you're trying to accomplish that. But if they're heading in the right direction, you should accelerate that. And if it brings people out of poverty and it causes less pollution overall, that's a winner. I think that's a way better solution than trying to we're trying to do it to China too, right? So we're trying to China, a bunch of other countries, Vietnam, the United States has a lot of enemies, obviously. So one of the things we try to do is you try to sort of tax them into oblivion or don't trade with them. That doesn't necessarily help the world. And we're starting to reevaluate a lot of those things, at least in the States, and take a look at, hey, if countries come out of poverty, is it a better situation for the world? Historically, it has been. And so we should think about that when we create these taxation policies. And sometimes I think the EU looks inward instead of outward. That if the world's going to change, it's going to happen because of the EU. That's probably true on some level, but the EU is not a huge landmass, and it's not creating as much pollution as some other parts of the world. I'd rather see the other parts of the world slow it down in terms of pollution and raise up their economy and electrify themselves. That's where I think the long term will go, and we'll get to a better, faster solution than things that are being proposed right now. But it needs to be debated. And I'm not sure there's a lot of debate going on right now. I think there's a lot of obstinance on everybody's part, which is not healthy. That's what I see from my little perch in America, is that I would like to see things go better in the world. And we just are not quite there yet. And sometimes we miss the gains. We miss all the good things that have happened. We really have missed the good things that has happened recently and are happening right now. And we should use them to our advantage. That's me. So let's take a quick break here, because after the break, we're going to talk about sort of whale dung, acoustic noise, and the effect that wind turbines out in the ocean may have on sea mammals. We'll be right back.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
All right, welcome back to the Uptime Podcast. We have a really interesting segment talking about noise on the seafloor and what its effect on sea mammals. And Vineyard Wind, which is a wind turbine farm that's going to go off the coast of Massachusetts here in the next year or two. Vineyard Wind is a joint venture between Avangrid and Copenhagen Infrastructure Partners. So they're working with the University of New Hampshire to deploy a passive acoustic monitoring device to record ambient sounds and marine mammal species vocalizations in their Vineyard Wind lease area. So what they're planning on doing is they're going to put a monitoring device in the water 30 days before construction starts, and then they're going to monitor what's happening with, I guess, the whales and the dolphins and whatever else is running around over there. They're going to listen for 3 years after to see how the sea mammals are faring, and also what kind of noise is coming out of the wind farm. Obviously, when they're driving in the pilings, that's going to make a decent amount of noise, and they're concerned about that, and that it may be causing stress into the local sea life. And this whole concern about sea life and loud noises in the seafloor is I thought was validated, actually. I thought there was been a lot of academic data to say, hey, noises above a certain level make all the sea life go crazy and they don't like it. And I saw, and Rosemary, you may have saw this too. There was a LinkedIn post recently showing the path of a whale in a bay with shipping corridors, where the whale appeared to be avoiding the shipping corridors, like bouncing back and forth like a game of Pong. That's what it kind of looked like. With this whale is moving around, I thought, oh, okay. Maybe there is a problem with the whales and in the shipping corridors, and there must be a problem with wind when you start driving those pilings in. So at least there's somebody's going to start monitoring it. And Rosemary, does it make sense that we should start monitoring the noise off of offshore wind turbines, because we're just really going to start massively deploying them worldwide? We just don't know a lot what's going to happen, do we?
Yeah, I mean, I think it is good to monitor, and it's interesting that you raised shipping, and I know you want to talk about that more later, but I think all the evidence shows that we're already disturbing marine mammals a lot with our activities in the ocean, and we haven't understood that very well so far. So I think it's definitely important to monitor, because then you'll get ways to minimize the impacts. But I don't like to see people, only worry about an issue when it relates to renewables. This is the noise in the ocean is an issue, and it shouldn't only be when it applies to wind turbines that we care about it. So yeah, I'm in favor of the monitoring, but it shouldn't be a reason to halt all wind turbine installations, but keep on doing anything else noisy that you feel like in the ocean. I wouldn't like to see that outcome.
Yeah, I'm with you on that. So I think you and I are on the same page in terms of, if it's too noisy, that's not healthy to any of the sea creatures. So let's keep an eyeball on it. So I started to do a little bit of digging just to see what research had been done, and there was an interesting study done on 9/11 in 2001, where shipping essentially stopped. Most everything stopped on 9/11, at least in the United States, where some researchers up in Canada were monitoring some whales, and at the Bay of Fundy, which a place I haven't been to, sounds beautiful though, and they were collecting whale dung before 9/11, during 9/11, and after 9/11. And I guess whales emit. Well, yeah. I mean, somebody's got to do it, right?
Someone's going to do it.
So they were collecting whale feces, and it sounds like whales, when they're stressed, emit hormones, which then are expelled in their feces, and researchers can study that, so they can kind of tell when whales are stressed. So pre 9/11, whales are stressed. 9/11 happens, everything quiets down, shipping kind of stops for the most part in the United States for at least a couple of days, and the whales seem to be happier, have less of this hormone in their tongue. So in that case, they thought, well, okay, there must be a correlation between noise and stress, and it's probably a good correlation. At least it has something to do with it. So I decided to dig a little bit deeper, and there was a meta study done back in 2019 on the effects of ship noise on marine mammals. So they're looking at multiple studies, and what the literature shows is that they don't really know all that much. There's been a lot of studies, and there's been a lot of interest in it, but they haven't correlated specific noise levels with specific kinds of stress. And because there's such a wide variety of sea life, that maybe some mammals are more impacted than others, there's just a lot of data, but none of it seems to sync up. Which I thought was interesting, because there is a big amount of effort being placed on renewables when they get deployed into the ocean. And Rosemary, what are the kind of things have you seen where they're driving pilings and where they're trying to quiet that down? Have you seen some of the tech around that?
No, I haven't seen that. I've been paying quite a lot of attention to the environmental impact assessments that they're doing, especially the ones that they're doing in Australia at the moment, because we, the first developers or wannabe developers of offshore wind farms in Australia have to kind of, guide the whole regulatory framework to, come into existence. Sure. So it's interesting to see what, they don't have any regulations they have to follow. They're kind of, doing some impact assessments and then telling the government what regulations they should make. Or I guess that's, their goal. And I know that they're doing a lot of stuff, seeing what kinds of animals are in the area, what their normal behavior is, what kind of birds are flying around, all that sort of thing.
Sure.
And I think that it's a really good consequence of of renewables that you can actually have this, positive impact on science related to these animals. I know someone at GE told me that most of the funding for bat research in the US actually comes from the wind industry, because wind turbines were having, there were problems with certain bats being killed by certain wind turbines. And so
Sure.
they put a bunch of money into research to understand the bats better, and and that would allow you to make changes to your technology that would protect them. But as a consequence, we know more about bats now, and there's more opportunities for bat researchers, which I'm sure those scientists are happy about. And I guess we'll see the same thing here. It's crazy that we really don't know what makes a whale happy or unhappy. And we'll learn more about that, which is a good thing in itself, unrelated to wind energy. And I'm sure the same thing will happen with mammals and other marine wildlife, as has happened with birds and bats. We'll find technologies that can minimize the impact on these animals without forcing us to just, abandon wind energy altogether, because obviously other forms of energy generation also have big impacts on the environment, not least climate change.
So I've seen a couple of things about the amount of noise that they're allowed to emit. I think it was in Denmark, actually, where they were talking about like 168 decibels underwater, of trying to limit the noise to that, which 168 decibels is fairly loud, right?
Wow.
I mean, that's
very loud.
beyond jet engine loud. Yeah, that's really loud. So I've seen two devices, and I haven't seen a lot of detail on either one of them, but you hear the little bubble curtain, right? That's what I read a lot about is they got this curtain of bubbles, which act as a absorber of noise, which I guess is kind of cool, right? That makes sense.
Yeah.
And the one I actually saw a little YouTube video on was they described as rings of upside down coffee cups in a tiered structure, like a layered cake sort of thing. So it's like these rings of upside down coffee cups, which was actually being used. Yeah, I have to pass it along to you. So they're dropping these rings down into the ocean around these pilings they're driving, because it acted like a muffler. Which, if you ever look at a car, it's sort of the way a car muffler works. It sort of runs it through a bunch of baffles. And so that's how they were reducing the noise in the water. I thought, wow, okay, so there is actually some really decent science going into reducing noise into the ocean, which is a lot better than you can say for like the shipping industry at the moment, that the renewable industry is really looking at it, which is, hey, that's great, right? We should be encouraging that. But I think we should try to follow up on some of the technology there, because as you said, there's not a lot of regulations about it, particularly in the States or in Australia, but there will be. And
they don't know what they should be regulating.
Sort of what that criteria is.
Yeah, and the science, that's what you need to tell you. Like you can't just never do anything in case it causes a harmful impact on something. You have to, proceed cautiously, but still proceed. Otherwise we're just stuck with all our existing problems that will never get any better. So no, I think it's good, and I am seeing a lot of research now, and I think that's good place to be.
Yeah, I totally agree. So we're going to take a short break here, but when we come back, Rosemary is going to tell us about the lithium-ion battery gigafactories, and are we building enough to keep up with the pace of new battery tech?
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS, so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
All right, welcome back. Rosemary is going to give us a brief discussion about lithium-ion batteries. Rosemary, the table is yours.
Okay, so I saw an article that was predicting or projecting, what all of the effect of all of these battery gigafactory announcements that we've seen, what's that going to add up? And so when you add up all of the gigafactory announcements, then you end up with a pipeline of production 6 terawatt hours annually by 2030. And at 6 terawatt hours, that would mean that the world could make about 109 million EVs each year, with, obviously the batteries for the EVs. And currently we're at, the current record for 2021 was 6.6 million. So that is a big expansion in, the less than a decade, but it's probably not as many as would naturally happen if we had no constraint over the supply of batteries. And just for reference, Elon Musk says we need we don't need 6 terawatt hours. We need 300 terawatt hours to be able to totally transition the whole world's electricity and heating to renewables. And I mean, this is a point that's really, I think you see a lot of disagreement amongst many smart people, interested people. I personally think that we're going to need less storage than that overall for a variety of reasons I won't go into now, or we would never get through the rest of this podcast. But I think that we're going to need less storage, and I think that we're not going to use as much lithium ion as a lot of people think storage equals lithium ion batteries. And I think we're going to see a lot more pumped hydro, especially, and probably maybe also flow batteries might, play a significant role. And to a certain extent, that depends on,
right.
How many lithium-ion batteries can we make? Because the reason why I think people think that, lithium-ion batteries are going to dominate is because if you, continue current trends for, the increased demand for lithium-ion batteries and the reduced cost, you continue those trends through just a few years, very quickly it becomes impossible to use any other technology because they're just more expensive. But we currently don't have all of the minerals in place that you would need to allow those price reduction and demand increases to continue the way that they have been. So I think that there's a lot of debate currently about how the future is going to look for lithium-ion batteries, and I think it's way up in the air.
But doesn't the outlook for lithium-ion batteries really depend upon that 300 terawatt hour number? That's the critical number. Whatever that number is, and we can have an argument if it's 301 or 299 terawatt hours. It doesn't really change the fact you're going to need a lot more lithium. Now, if Rosemary, if you're saying it's only 100 terawatt hours, and who am I going to believe, Rosemary or Elon? I'm not sure because I can't really weigh it, but it does make a big difference on what happens to the industries, right? 300 terawatt hours and 100 terawatt hours. There's a lot of terawatt hours in between those two. Someone's got to kind of get on the back of the envelope and start figuring that out, right?
Yeah, and I think that there are a lot of back of the envelope level calculations done, and you can get better depth, better accuracy than back of the envelope, but the assumptions are so wild that I don't think you actually get any closer to a good answer. But and I don't see actually that it's that number that's the driver. What I see is it's the technology and the economics that's going to drive what that number is. Because there's plenty of other ways that you can solve the problem. I mean, the simplest way conceptually to solve the electrification of the electricity grid is that you just have heaps of wind and heaps of solar panels and enough batteries to smooth all that out, so that we carry on exactly like we have before with fossil fuels. You still got energy on demand whenever you want to turn on the electricity tap. That's one way to do it. Very simple to describe, but I think if we end up not being able to produce the vast amount of batteries that we would need to make that happen, then people are going to get a bit more creative. So in the past, we adapted the electricity system to suit the generators that we had. So you have a coal power plant or a nuclear power plant, you can't really ramp it down at night, or you can't turn it off completely. So we had all this electricity generation at nighttime when no one wanted to use it. So you encourage people to use it by having off-peak power, and people started having off-peak water heaters and stuff like that. We'll do similar things, but to reflect the new technologies and their characteristics. So I think we're going to see a lot more flexible demand than we have in the past, because it's going to be a lot cheaper to do it that way. And then, in terms of the actual, what do we use for the storage that we do need? If lithium ion batteries continue just drop in price like they currently are, or they were up until this year, then yeah, you would see almost nothing else except for the really long duration storage.
Yep.
But if the prices go up for a while because of, like supply chain constraints, then you'll see other technologies come in. So pumped hydro is the most obvious to me because it can do that longer duration storage, and it's quite, it's very flexible,
Sure.
and we already know the technology. But there's also other kinds of batteries, so not just flow batteries, but also there's other battery chemistries that don't use all of the same minerals that might, become constrained, including you don't need lithium at all. You can, there's like sodium-ion batteries or, other technologies that aren't mature or cost competitive yet, but, if the price of lithium-ion batteries goes up and people just can't get them, I think that you'll see people quickly maturing these other technologies so that they can sell something.
No, I think lithium batteries are here to stay for the long term, and in that the chemistry is going to get simpler and simpler. They're going to remove the hard to find or hard to refine metals out of the batteries and replace them with something that's a little more generic. That's the whole point. And I as we have watched over the last 10 years, lithium has really, really made an impact because of the cars, the EV cars, that any new technology is going to have a gigantic hurdle to jump. It'd be like trying to jump over a lead acid battery in 1970. It's just not going to happen. It's just so much infrastructure around it. It's almost impossible to do. It's going to take someone like a Musk to basically build a factory out in the desert to overcome that. And I just don't see that happening at the moment. Now, I'm going to transition here to things that GE is doing because I think this sort of ties in terms of different philosophies. GE is looking at 3D printing concrete tower bases, which is totally different than anybody in the OEM space is doing. Why, Rosemary? Why is this a big deal right now? Why would you want to print a tower base?
Well, it's a big deal now. It's been a big deal for a while. I actually tried pretty hard to get a job with that group in GE when I was getting a little bit sick of de-icing, and I saw that the additive manufacturing group was doing really interesting things. I was unsuccessful in pulling that off, but I have kept tabs on what they're doing. They've got all sorts of additive manufacturing stuff going on. That's really cool. And one of them is related to towers and printing them from concrete. And I mean, this is an important problem because, everyone wants taller wind turbine towers. The wind speeds get higher as you get further away from the ground. So the taller your tower, the better resource that you can get at. But they're constrained because, to make a really tall tower, then you're going to want to increase the diameter of the tower so that it's stiff enough. If you need to keep the diameter the same so that you can, for example, transport these steel tubes on normal roads, normal trucks, then you're going to have to make them really thick if you want to make them stiff enough. So you'll end up using just way more steel, and so the economics don't work out, and that's why we have sort of seen towers sort of level off. They're not getting way higher anymore like they were 10 years ago. Right. So people are looking for ways to get around this, and there's a few different ideas, but one of them is that you could print the bottom part of the tower. You could print it wider, and then you don't need to transport this really large diameter tube to site. You make it on site.
Right.
So it's got potential to have a lot of impact.
So they're just talking about making the bases at the moment, right? And Kobad has been on the podcast. So we had Henrik Lund Nielsen on to talk about technology. Gosh, it's probably 2 years ago almost now. It's been a long time, and he got us in early to explain what the technology was, and we actually learned a lot behind the scenes of how the technology works and what they can do with it. I think where they're headed is the cost of steel is going to go up so much that if you can replace steel with concrete and you're not moving these massive pieces across the country, it's going to be less expensive. And GE is looking for ways to make wind less expensive or to lower their costs in particular. This is one way to do it if they can go higher with the tower, and if they can My guess is that they could go at about 30 feet right now, what was roughly a little under 10 meters. So if they can go 10 meters, that's a good bit. If they can get to 30, 40 meters, something like that, is it possible? Maybe it is. And if anybody can do it, GE and Cobot are going to be the two groups to pull that one off. So I think it's interesting technology to watch. It's cool. It's really cool. So last on our docket today, Rosemary, vertical axis wind turbines, cell phones, and solar panels. So a group up in Michigan called, I'm going to pronounce it wrong, obviously, Iridatum, is up in Brighton, Michigan, and they're designing a cell tower that can be placed in remote locations like Australia or Massachusetts.
We already have mobile phone towers in Australia.
Oh, you do?
For your
You're
listeners
so lucky.
that weren't aware. Yeah. Yeah. Sometimes they work.
Yeah, we're in the same boat, actually. We have one tower, and it actually blew over a couple years ago, so we've been living on borrowed time ever since. So they're talking about putting up a 150-foot tower that integrates a vertical axis wind turbine and solar panels, and then have a vanadium. Am I pronouncing that correct? Vanadium? Is that the proper English way?
I don't know.
Okay.
Maybe I'm saying it wrong too.
They're going to put a vanadium flow battery storage to provide power to the system. And the point is that they don't need any infrastructure. They can basically take a cell phone tower, which is a repeater station, and put it out in the wilderness, set it out there, and periodically check on it. And it sounds like they're also talking about putting some sort of diesel generator or something there because of emergency services. It really can't go down, so they need that thing to stay up. And if they had a solar eclipse combined with no wind for a couple of days, it may be in trouble. But so they actually have raised money, $15 million US, and are planning a pilot project in Michigan, Kansas, and Maine. I wish they'd come to Massachusetts, actually, for these towers. And Rosemary, does this sort of make sense that as the batteries get good enough and the wind power is working and solar is so efficient, do these projects become possible?
Well, yeah, but they've been possible for ages. In Australia, we have plenty of mobile phone towers or communication towers that are not grid connected. And there's a Australian flow battery company called Redflow. They don't use they're using a different chemistry. It's a zinc bromine flow battery, but they've got at least like many years of operation using solar panels and these flow batteries to keep reliable power supply to these remote areas. So I'm not sure exactly where it differs, and I haven't looked in depth to this new project, but for sure it's all mature technologies. The flow batteries have a lot longer duration than it would be really hard to achieve with a lithium-ion battery. You'd need a big one to get you through like a really cloudy few weeks or something like that. And I know that you expect me to say that the vertical axis wind turbine is a stupid idea, but here is the exact perfect place
Come
for
on.
it. You already see them powering, meteorological stations and all sorts of applications where you need simplicity, reliability, robustness. Those are the important things and not efficiency. You would definitely choose the simplest kind of wind turbine that you could, and that would be a really basic vertical axis wind turbine. So I think it all makes sense, and there's nothing stopping them from doing it. It's just integrating a few existing very mature technologies, and off you go.
So there you go, everybody. Rosemary has stamped her approval on vertical axis wind turbines. I didn't think that was ever going to happen. You heard it here today.
I always say
so let's go do it.
Horses for courses. That vertical axis wind turbines have their place, and this is their place. There aren't many other places for them other than this type of application. So that's exactly what they're suited to.
There you go. Well, that's going to do it for this week's episode of the Uptime podcast. If you're watching on YouTube, try joining us on Spotify and other audio platforms. If you're listening to us on Spotify, join us on YouTube also. So we'll see you here next week on the Uptime podcast.